Hi, I'm Mary Fowler. I'm a statistician. I work as a professor in the math department at Worcester State University, and I also work as a expert witness, mostly in racial profiling cases in Massachusetts. And so I want to spend a little time today talking about how to use statistics to prove racial profiling in court, and also a little bit about how it is to be a statistician in court. Um, so I'm gonna start with just some basic statistical inference using simulation. It's nice to have simulation because it doesn't have quite the level of mathematical prerequisite to understand as maybe normal theory does. And so I'm going to start with that. That's how what I usually do when I testify. And then I'm going to go into a little bit about a guiding case that has changed the way racial profiling is used in court or proven in court. Okay, and a little bit about the journey and of what's happened since then. So I want to start with this randomization. And the randomization is that I have set up a bag. And in this bag, I have black jewels and non-black jewels. And 45% are black and 55% are not black. And the experiment that I want to do is I want to take 12, I want to make a draw of 12 jewels and then count the number of that are black and record it. Okay, so I'm going to take some jewels out here. Oops. And in this draw of 12, I ended up with 5 black jewels. So I'm going to put those back in there. And I'm going to go over to the whiteboard and start a dot plot. So if you choose 12 jewels out of a bag, the number of black jewels is going to be somewhere between 0 and 12. So that's how I set up the axis. And I think I said 5. I had 5 black jewels. Okay. Let's do it again. So I'm going to go back in. I have to do this a lot of times to understand the distribution of the number of black jewels after a sample of size 12. So let's see. I have some jewels. Let me organize them. Okay, so in that little draw, I ended up with 4 black jewels. So over to the whiteboard. Let's continue to work on our dot plot. Okay, so I need to continue this. I need to do this a lot. And in order to facilitate that, we're going to use some computer-based simulation. I'm going to use the Rossmann-Chance apps. And so I'm using here the Rossmann-Chance applet collection. And we're going to we're going to model what's going on with the jewels by the probability of a black jewel. Heads will be black, 45%. And we took a sample of size 12, and we can draw a sample here. You can see we get 6 in this sample, and we could do it again and again. But we can also do is just put in 10,000 here, and we'll get a simulation of size 10,000. All right, and this is the number of successes along the horizontal axis, but we could also transform that to the proportion of successes. All right. Okay, so these are the graphs that I got from the Rossmann-Chance applet. And in order now to use this to do a hypothesis test, I want to show you something I have here, which is that I have a basket, and in the basket are jewels. Okay, and the basket has a label on it, and it says, and let me make this readable here. 45% black, 55% not black. But I can't see in the basket. But what I want to know is, can I believe that? So what we're going to do is what I did right before I made the video here is I went inside the basket and I took out a handful of jewels, all right, 12 jewels. And in this scoop of 12 jewels, there were 8 black and 4 non-black jewels. So does this provide evidence that the true proportion of jewels that are in the basket that are black is greater than 45%? Okay, so that's our question. So here's how we set up the hypothesis test. The null hypothesis is that the proportion is the 45%, and the alternative hypothesis is that we're going to use greater than 45%. So if the null hypothesis were true, if P naught were in fact 45%, how likely is it that we would see 8 or more jewels in a draw of 12? So the p-value is the probability under the null hypothesis of observing an outcome as extreme as or more extreme than what we observed. That is, what is the probability of observing 8, 9, 10, 11, or 12 black jewels? So the way this works is if this p-value or if this probability is very small, then it provides evidence against the assumption of the 45% in the basket, right? Against the null hypothesis. So p-value, there are some traditional cutoffs, but in general, what we're looking for is if the p-value is small, then it challenges the null hypothesis. All right, so what we got was that if the label is correct and there are 45% black jewels, we take a sample of size 12 and we get 8, we would get 8, 9, 10, 11, or 12, according to our simulation, 11.42% of the time. Now, 11.42% is not all that rare of an event. It's not that small of a p-value. It's not that rare of an event. And so, in fact, choosing 8 out of 12 black from the basket does not provide us evidence against the label, the 45%. So